So, good afternoon, students. And today we will continue with our chapter which we are doing, motion. And before going into the next topic, let me have a brief discussion of the last day class so that we can recall that what was and how much we have done in our previous classes. Now, students, before going into the next portion of this chapter, can anyone say me what do we mean by motion? How we can define motion? Okay, Nandini, unmute yourself, Nandini.
Yes, sir. Sir, motion is the phenomenon in which an object changes position over time.
Okay, the object changes position over time. Okay, correct, Nandini. So we can define motion definitely as that when a body changes its position, when a body changes its position with respect to the time, that will be called a motion. And now, students, our next topic is distance travel and displacement. Okay. Now, what is a distance? Also, in the last class we have discussed. Can anyone recall what do you mean by displacement? Distance first. Okay, Swadha. Swadha, unmute yourself. You have raised your hand. Unmute yourself. Swadha. Yes, Swadha. Unmute yourself. Okay, Swadha, I think some audibility problem from your side. Okay, no problem. Yes, you can mute yourself. Okay, okay, Nandini again. Nandini, you can unmute yourself, Nandini.
Yes, sir. Sir, distance is the actual path traveled by a body.
Okay, fine. Okay, Nandini, correct. The distance is the actual path traveled by a particle or traveled by a body. Definitely correct. And now, can anyone recall? In our last class, we have also discussed the difference between distance and displacement. Can anyone say what is the difference between distance and displacement? Anyone? Difference between distance and displacement. Any of the student? Okay. Ritika. Ritika, you can unmute yourself.
Yes, sir.
Yes, Ritika. Difference between distance and displacement.
Sir, distance is the longest path traveled by any object, while
Okay.
displacement is the shortest path between the final and initial point.
Okay. Definitely correct. Very good. Okay. Just. Okay. Yes, definitely, student, that when a body moves from one point to another, the distance travel refers to the actual length of the indirect path, whereas displacement refers to the straight line path between the initial and the final position. Now, if I ask you that between distance and displacement, is there any object, or we can say that between distance and displacement, which physical quantity can be zero? The value of which physical quantity can be zero between distance and displacement? Okay, very quick. Some of the students have raised their hand. Okay, fine. Okay. Okay, just a moment. Just a moment. So now, students, okay, we will be coming to the topics, the scalar and the vector quantity. Now, students, scalar quantity definitely are those quantity which has only magnitude like length, area, volume, speed. And vector quantities are those quantities which along with the magnitude has the direction associated with them. Okay. So if among the distance and displacement, we have to classify that which one is scalar quantity and which one is vector quantity, then definitely we have to see, just a minute. Let me admit the students. Okay. Then definitely we have to say that distance is a scalar quantity because it has magnitude only, but it has no specified direction. And then displacement is definitely a vector quantity because it has magnitude as well as direction associated with it. The distance definitely traveled by the body cannot be zero, but the final displacement traveled by the body can be zero. Okay, just a moment. Let me admit the students. Okay. Okay, fine. So now comes to now we are coming to the next topic, that is uniform motion. If the body covered equal distance in equal interval of time, it is said to be in uniform motion. And if the body do not cover equal distance in equal interval of time, it is definitely said to be in non-uniform motion. What is the nature of the graph obtained for the uniform motion? It is a straight line. And if it is a non-uniform motion, it is a curved line. Okay. We also discuss speed, velocity, and today we will be starting with acceleration. Okay. Acceleration. And what is acceleration? Acceleration is defined as a rate of change of velocity, with time. Now, this acceleration is a change in velocity by the time taken for the change. So if we are considering the final velocity to be denoted by v and the initial velocity to be denoted by u, you can see in the screen. You can see over here in the screen. Then a is the acceleration and v minus u, that means final minus initial velocity by time taken. So v minus u by t. This is the expression for the acceleration. That is the final velocity minus initial velocity divided by the time taken. Okay, so this is the expression for the acceleration. Okay. Now, students, all of you see the SI unit of acceleration is meter per seconds. Meter per second. Just a moment. Let me do some settings. Just a moment. Yes. Now, students, all of you look to this graph which is there in your screen. Okay. Look to this graph which is there on your screen. On one axis, we have plotted the velocity, and on another axis, we have plotted the time. When with time, the acceleration is increasing, this graph, this is called positive acceleration. When it reaches to the plateau stage, that means stagnant, this is called zero acceleration. Okay, Ritika, speed and velocity. Okay, I am explaining once more. And when with time, the acceleration value is decreasing, then it is called negative acceleration. So three types of acceleration we have to study. That is a positive, zero, and negative. Okay, Ritika has said to once again explain. Just a moment. Just a moment. Speed. Yes, Ritika, just I'm seeing your question. Speed and velocity. Okay, Ritika, let me come to the slide. Yes. Speed and velocity. See, Ritika, speed is definitely the distance traveled by time. Okay, distance traveled by time. But velocity is distance traveled by time in a specific direction. Okay, specific direction. Is it clear, Ritika? Ritika, your doubt is clear. Through the chat box, you can give the reply. Okay. Okay, fine. Okay. Now, one student has entered with the, let me, just a moment. Okay, I repeat once again, the uniform acceleration and the non-uniform acceleration, you can see students on one axis, we have plotted the velocity and the other axis, we have plotted the time. So when the velocity increases by equal amount in equal interval of the time, the nature of the graph obtained is a straight line. And if it is a non-uniform acceleration, then definitely it is a curved line. That means the body is covering unequal distance in equal interval of time. Remember here, time interval is equal, but the distance cover is unequal. Okay, all of you got this? Till this is clear to all? Till this is clear to all? Through the chat box, you give me the reply. Okay. Okay. Okay, Swadha. I'm coming to that point. Swadha has asked once, just a moment, let me see further questions. Okay. Swadha has asked to once again discuss the formula for the acceleration. See, Swadha, I'm using my screen as a board also. Let me go with the text. See, Swadha, if suppose A is a acceleration, okay? A stands for acceleration. V means our final velocity, okay? When the body reaches to its final velocity. And if we are saying U to be the initial velocity, then final velocity minus initial velocity divided by time, this is the expression for the acceleration. Acceleration is the rate of change of velocity. Okay, rate of change of velocity. Whenever we are saying a rate of change of velocity, then definitely it means that we have to calculate the change in velocity over a time period. How much time is taken? Okay, so the V minus U by T. Okay, fine. Okay. Okay. Now see students, the next concept we are coming to retardation or negative acceleration. Now, if we are saying the velocity of the particle is increasing with time, then definitely it is a positive acceleration. But if the velocity decreases with time, then it will be called negative acceleration. And the word negative acceleration means retardation. Okay, just a moment. Retardation. So here in this graph, you can see the retardation. In this graph, you can see retardation. Now, all of you see this graph. With the passage of time, the velocity of the body is decreasing. Okay. And that is why we are saying that this is a case for the negative accelerations. Okay. Is it clear to all? Now, students, Here is a set of questionnaires. Okay, here is a set of questionnaire with the answer. You can see very well that what type of motion is represented by the graph. The answer is simply uniform motion. But can anyone justify this answer? Let me interact with you all. Can anyone justify this answer? Okay, Harsh. Harsh, unmute yourself.
Because, sir, it is a straight line graph.
It is a straight line graph. What does it mean? Indicate? Harsh, what does it indicate?
That the object is covering equal distance in equal interval of time.
That the object is covering equal distance in equal interval of time. Very good. Good, Harsh. Well explained. Next, for the next question, a stone describes a circular path with a constant speed. State the type of motion of the stone. So you can very well understand the stone is going on in a circular pathway. And what type of motion it is? It is definitely the accelerated motion. Can anyone say why we are calling this as an accelerated motion? Why we are saying this an accelerated motion? Okay, Swadha, unmute yourself. Okay, okay, Swadha, I think some network issues definitely from your side. No problem. You can also write the answer in the chat box. No problem with that. Yes, Ritika has already responded through the chat box because the direction on the velocity changes. Okay. Okay, Ritika has answered. Next question was, under what condition is the magnitude of the average velocity is equal to the average speed? When the body moves in a straight line. Now, student, here, one more thing. Students, average speed and average velocity, both concepts are clear because we have already discussed average speed, total distance by total time, and average speed and average velocity, initial plus the final velocity by the time taken. Okay, total velocity by the time taken. Now, student, after this, we will come to a very important topic, the graphical representation of the motion. Okay, the very important, this students. This is a extremely important topic, and from here, many conceptual questions can be also asked in the examination. Student, all of you, please look first. Okay, if on one axis a distance is plotted and another axis a time is plotted, then this is called a distance time graph. You can see, students, many forms are given over here. One, you can see fast steady speed continuously increasing, steady speed continuously increasing, but after some time it becomes stationary. That means no change. And then again returning to the start, that means decreasing. And this green color graph indicate that definitely with time the speed is getting faster and faster. So here are some of the conditions under which, or we can say, the variation occur. In the first condition, we can say it is a steady speed. Then you have the fast steady speed, then the stationary, that means after which there is no change, and then returning back to the start. And in this graph, it is saying that it is getting faster and faster. Okay, so these are the different conditions for the distance time graph. Did you understood the different conditions, student? Did you understood the different condition of the distance time graph? Through the chat box, you give me the reply. Okay. 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 Can anyone explain me the different condition of this graph? Harsh, can you explain the different condition of this graph?
In the in the first condition, the in any of the condition of this graph, no uh,
Yes, Harsh, go on. Yes, Harsh. Did you got disconnected? No, you are there still. Yes, Harsh, speak up. Okay, no problem. Ritika, please elaborate the graph which is there on your screen.
Yes, sir.
Yes, Ritika. The different condition, for example, this blue color line, then this pink color, green color, what does it indicate? Okay, let me unmute you.
Yes, sir.
Yes, Ritika.
सर जो ब्लू कलर का है वो एकदम स्ट्रेट लाइन में जा रहा है तो वो फर्स्ट होगा क्योंकि वो
Hey,
वाई एक्स
what indicate? What does it indicate?
सर द ग्राफ इज इन यूनिफॉर्म मोशन
Okay, correct, very good. And steady speed, pink color,
सर एक्सक्लरेशन
it is going as first steadily, then decreasing, and then returning to the start. That is negative. Okay, fine. Good, Ritika, very good. Well explained. Uh, okay. Now let us come, student, to the next type of graph, that is velocity time graph. Velocity time graph. Just a minute. See, students, condition one, when the speed remain constant, student, you must remember the nature of the graph, okay? Because question will be asked from here. When the speed remain constant, it is a straight line parallel to the x-axis, okay, to the time axis. You can see over the graph. So the condition will be given to you that draw the graph when the speed remain constant, okay? Draw the graph when the speed remain constant. So this is the case when the speed is remaining constant. So it is a straight line parallel to the time axis. Okay. Next. See, the speed time graph when speed changes at uniform rate. Here you can see the nature of the graph. It is a straight line. Okay, it is a straight line. Next. Uniform retardation. That means here you can see this graph, which there I have put a tick mark. The value or the acceleration is negative. That is a retardation. Uniform retardation. That means the body continuously is decreasing with time. Now, all the students, there is assignment for you all. There is assignment for you all. All of you in your sheets, you draw these graphs. Okay? You draw this graph and you come to the conclusion that what do this indicates. Okay, this will be an assignment for you all. All the student, you can take the screenshot of this graph and take a pic of this, and you you will be depicting that what is the nature of this graph, what type of motion it is indicating. Okay. I think all of you have taken the pic. Okay. Okay. Derivation of the equation of the motion is deleted from our syllabus, definitely. Now, students, let me share my, just a moment. Okay. Students, my whiteboard is visible to you? My whiteboard is visible to you? Through the chat box, you give me the reply. Okay, fine. Okay. Okay, just a moment. Just a, okay. Just a moment. Okay, all of you write down the question. Write down. Just a moment. Yes, just a moment. Okay, all of you write down this question. Write down. The odometer of a car, the odometer of a car reads, the odometer of a car reads 2000 kilometer, 2000 kilometer full stop. If the trip took 8 hours, if the trip took 8 hours, if the trip took 8 hours, comma, calculate the average speed of the car, calculate the average speed of the car in kilometer per hour and meter per second. I repeat my question. The odometer of a car reads 2000 kilometer at the start of a trip and 2400 kilometer at the end of the trip. If the trip took 8 hours, calculate the average speed of the car in kilometer per hour and meter per second. All the students will solve this question and then I will enable your videos and you will be showing the solution to me. Okay, Harsh, you have said that you have solved. You can, Harsh, you can show your video, that is a copy work, how you have done. You can show it to us. Harsh, you can start your video. Okay. Okay, it's correct. That is definitely okay. Yes. The thing is that it is given that it is 200 kilometer at the start and 2400 kilometer at the end. So the total distance covered will be the final minus initial, correct? Yes. And then divided by the time taken. Next, any other student? Sodha, you can also show your work to me. You can start your video towards your copy. Towards your copy, you can start. I want to see the work done. Okay. Okay, students, within, yes, Sodha. Yes, Sodha, okay. Okay, Ritika also. Okay, student, within a few seconds, our class will be going to end. So student, you will solve this question today, and again in next class, we will discuss this. Okay. Thank you, students.